Welcome back, or perhaps welcome for the first time. You've stumbled into a different kind of space story, one without explosions, without countdowns, or thunderous rocket engines. There are no heroes in silver suits here, no parades, no speeches, no ticker tape. No, this story begins in a basement. Not the kind filled with cobwebs and forgotten furniture, but a workshop basement, buzzing with fluorescent lights, heavy with the scent of industrial fabric, machine oil, and sweat. Here, in a quiet corner of Delaware, in the 1960s, a team of women and a few quietly obsessive engineers were sewing history together, quite literally. This is the world of the unsung suit makers, the people who didn't ride the rockets, but built the only thing separating those who did from the vacuum of space. Imagine this. Somewhere on Earth, while the world watched astronauts lift off from Cape Kennedy, you were down there in a converted lingerie factory, stitching rubber-coated fabric through thick gloves, your fingers raw, your neck tense, all while knowing that a single, invisible pinprick could be the reason someone doesn't come home. That's the rhythm of tonight's story. A slow, immersive descent into the world of spacesuit development. Not from the glamorous angle, but from underneath it. We're going to explore what it was really like to build the thing no one ever thinks about. The only true barrier between a human body and the merciless vacuum. This episode is divided, gently, into 4 segments. First, you'll step into the daily life of a Playtex seamstress in the Apollo era. A surreal mixture of factory work, technical improvisation, and unbearable pressure. You'll feel the hum of the sewing machines, the scratch of starchy nylon, the ache in your back as you lean over reinforced seams again and again. Then, we'll zoom in closer and tell the unlikely story of how a company known for making undergarments defeated the military-industrial complex to win the Apollo suit contract. Yes, Playtex beat out Hamilton Standard and its army of engineers with nothing but rubber, nylon, and good old-fashioned stubbornness. There were arguments, lawsuits, even sabotage. Third, we'll explore the strange, quiet mysteries of the suits themselves, the bizarre testing rituals, the lost technologies, the failed experiments, the cooling tubes that looked like spaghetti, the miniature fans that had to work inside helmets, and the moments when things quietly didn't work, but no one noticed. And finally, we'll drift into the contrast, the NASA leadership offices in Houston, where decisions were made not with thread, but with memos and budget meetings, where the battle wasn't over sewing technique, but over funding, politics, and PR. So get comfortable, loosen your shoulders, let your mind wander. This isn't the kind of space story that demands attention. It's one you can drift in and out of, the kind that rewards stillness, a tale of quiet hands, uncelebrated labor, and the beautiful absurdity of building moonsuits in a basement. It begins not with a countdown, but with a clipboard. You clock in, it's early, still dark outside. The factory smells like dusted fabric and warm oil. You pass under humming fluorescent lights. Your fingers are already sore before the day has begun. Your station is one of 20, each identical, each surrounded by tables scattered with stiff white cloth, plastic overlays, and curved metal rulers. You are not a scientist, not a pilot, not a face that will ever be broadcast from inside a helmet on national TV. You are a seamstress, and you are building the only suit anyone will ever wear on the moon. Your employer, not NASA, not the Air Force, not a government lab with blinking computers. You're working for the International Latex Corporation, specifically the Playtex division. Yes, the one that makes brass and girdles. It sounds odd now, but it made sense then. After all, who knew more about shaping and supporting the human body than the people who'd spent decades doing just that? Your fingers move steadily. Each stitch must be precise, minus 1/64th of an inch apart. You're not sewing clothing. You're creating a pressure envelope, a skin that must hold in life itself. The suit has 21 layers, some for pressure, some for temperature, some to protect against micrometeoroid impacts. Every layer adds thickness, stiffness, resistance. Try folding it. It snaps back. Try bending it. You have to wrestle it. Your day is spent feeding this layered, uncooperative material into a modified industrial machine. The needle punches down, whirs, then pulls. Over and over. Some of the women here used to sew corsets. Others worked in airplane factories during the war. Everyone has calluses. No one complains out loud. You sew standing up. There's no room to sit. You lean into the machine. A tiny sweat line forms under your brow. It's always warm here. Always. When the machine jams, and it will jam, you stop. Unthread it. Rethread it. Reset the tension. Try again. Every few hours, a test technician stops by. He collects a finished arm segment, or glove, or joint. They vanish into a back room where pressure chambers await. The suits are pressurized, submerged, twisted by robotic arms, scanned with X-rays. If a seam leaks, it's rejected, sent back, unpicked, redone. You've worked on the same elbow joint for 3 days now. Still not quite right. There is no good enough. There is only it holds, or it doesn't. Outside, in the press, astronauts are becoming heroes. But here, you don't know who's going to wear this one. They don't tell you. You write your initials on the inside panel, tiny, in Sharpie. It might be scrubbed off before flight, but you still write it. You need to remind yourself that you were here. Sometimes you hear them joke, the engineers, that if one of your seams fails during a moonwalk, the astronaut might puff up like a balloon. They laugh nervously. You don't. For you, it's not funny, because you know that these seams are the last thing keeping the void out. You've stitched a barrier between heartbeat and vacuum. You go home. Wash your hands with hot water to loosen the ache in your joints. You think about that one elbow joint again. Did the curve pull too tight? Was the tension just right? You fall asleep, hearing the sound of the sewing machine. Whir, snap, pull, whir, snap, pull, and tomorrow you'll do it again, because that's what it was really like to be a spacesuit tailor. Let's go back now. Not just to the basement, but to the boardrooms, the drafting tables, the courtrooms, the garages filled with blueprints and frustration. This is the story of how one of the strangest partnerships in aerospace history quietly outmaneuvered the aerospace giants. Playtex versus NASA's preferred contractor, Hamilton Standard. A battle fought not with rockets or money, but with thread, rubber, and relentless persistence. It begins in the 1950s with an unlikely man, Len Shepard. He didn't look like a space race hero. He didn't carry a slide rule or wear a pocket protector. He wore dress shirts and suspenders, and he worked in undergarments. But Len was no ordinary clothing designer. He was a senior executive at Playtex, and deeply proud of the company's expertise in crafting complex, body-conforming garments, brass, girdles, corsetry. not exactly high-tech to the public eye, but to Shepard, these were engineering problems as real and exacting as any rocket nozzle or guidance system. In 1955, Playtex formed a specialized branch called ILC, the Industrial Latex Corporation. Its original goal: create medical gloves and support gear. But by the early 1960s, NASA was looking for something very different. They needed a spacesuit, not just a coverall, a self-contained survival system. A suit that could be pressurized like a tire, but still allow a man to walk, bend, grip, kneel, even climb. It had to protect from radiation, from micrometeoroids, from 500-degree heat and minus 250-degree cold. It had to survive sharp rocks, moon dust, vacuum, and it had to weigh under 100 pounds. The giants of the defense industry lined up to pitch their prototypes. Hamilton Standard, already building life support systems for aircraft, seemed like a sure bet. They had money, influence, experience. Playtex, a lingerie company based in Newark, Delaware. They were laughed at, but Len Shepard didn't laugh. He recruited a strange and brilliant team of designers, engineers, and craftspeople, many of whom had never even seen an aircraft up close. One of them was Abe Silverstein, an engineer with a background in rubber products. Another was Emmy Daniels, a master pattern maker who had once designed ballet costumes and post-surgical support garments. And then there was Lee Silver, a quiet, obsessively precise lead engineer. He didn't say much, but he had a mind like a pressure gauge, always checking, adjusting, correcting. Together, this unlikely crew began prototyping suits, not in secret government labs, but in back rooms and side offices. Between shipments of medical gloves and girdle liners, they used whatever they could: rubber from tire tubes, nylon from parachutes, even metal wires from piano strings, to create flexible, self-supporting joints. And they were doing something the big companies weren't. They were treating the suit like a second skin, not a machine, not a pod, but a garment. Each prototype took weeks to complete. Each test took even longer. They built articulated joints with convolutes, those accordion-like ripples you've seen in old astronaut photos. They designed fingertip sensitivity into thick gloves, using layered fabric tensions and glove fingernails made of molded silicone. They even solved the torso twist problem by sewing a hidden rotary bearing into the waist, letting astronauts rotate their upper body while pressurized. The results were stunning. Astronauts could actually move, climb, crouch, twist, point. NASA took notice. In 1962, they launched a formal request for proposal for the Apollo suit. Playtex's ILC division submitted their model, dubbed the A5L. Hamilton Standard submitted theirs too, but it was heavy, bulky, rigid. Playtex's suit was more wearable, more human, more real. But then something odd happened. NASA awarded the contract to Hamilton Standard anyway. Playtex had technically scored better, but Hamilton had the name, the history, the political safety. It was a decision made in a boardroom, but not accepted quietly. Playtex filed an official appeal. What followed was months of conflict, meetings, protests, internal chaos. Eventually, NASA agreed to an unusual arrangement. Hamilton would be the prime contractor, but Playtex ILC would be the subcontractor for the actual suit. In other words, Hamilton would run the project, but Playtex would build the suit. Len Shepard wasn't pleased, but he took the deal. It was better than nothing. Work began. Prototypes were tested. Deadlines crept closer. And then sabotage. Hamilton engineers, uneasy about Playtex's rising influence, allegedly began modifying test results. They rejected suit components, changed specs. They were trying to push Playtex out from inside the contract. It backfired. NASA intervened, quietly but firmly. They removed Hamilton from the program. Playtex ILC was now the sole contractor for the Apollo suits. They had done it. The bra company had beaten the aerospace industry. In 1967, the A7L suit was approved for Apollo. 2 years later, it became the suit worn by Neil Armstrong and Buzz Aldrin on the moon. No one knew it at the time, but underneath the dust, beneath the layers of Teflon and beta cloth, were seams sewn in Delaware. Some by hands that once stitched corsets, some by minds that never went to engineering school, and all of it held together by belief. Belief that the body was something worth protecting, that a suit was not just a machine, but a kind of promise, and that sometimes even a basement is close enough to the stars. Let your mind wander now into the folds of cloth, beneath the pressure bladders, into the strange little secrets sewn into every Apollo spacesuit. Because while the outside of the Apollo A7L suit may appear sleek, bright, white, polished, iconic, its interior was a quiet maze of mystery. Not the kind of mystery that makes headlines, but the kind that slowly reveals itself, layer by layer, as you listen and begin to imagine. Let's take a slow walk, not through space, but through a suit itself. One stitch at a time. Start at the outermost layer, the thermal micrometeoroid garment. This layer, the one you saw in every photo, was not what most imagined. It wasn't metal, it wasn't hard armor, it was fabric, and not just any fabric. The outermost shell was woven from a material called beta cloth, a Teflon-coated glass fiber designed to resist both fire and micrometeorite puncture. Beta cloth had a strange feel, stiff, yet slick. If you rubbed it between your fingers, it wouldn't fray, but it wouldn't bend easily either. Tucked under this were layers of Kapton and Mylar, materials more often found in electronics and spacecraft insulation. Kapton, a brilliant amber-colored film, was heat-resistant but fragile. Mylar, reflective and silvery, helped maintain internal temperature. These layers were stacked in repeating sequences, as many as 13 layers, to protect astronauts from space's searing heat and bitter cold. Imagine wearing a coat made from Christmas tinsel and surgical tape. Only it could save your life. Now go deeper. Beneath the insulation was the pressure bladder layer. This was made of urethane-coated nylon, and it did exactly what it sounds like. It held pressure like a balloon. When the suit inflated, it became stiff, like a giant Michelin Man. That stiffness made movement nearly impossible, unless the joints were designed to bend in just the right places. Hence the famous convolutes, those rippled sections at the elbows, knees, wrists, and ankles, not decorative, not redundant, but mechanical in their softness. Beneath that bladder was a restraint layer made of Dacron, a polyester web that prevented the bladder from ballooning uncontrollably. Think of it like an invisible exoskeleton, not rigid, but commanding shape. But even deeper, you find the comfort layers, cotton, nylon, moisture-wicking materials. Each astronaut had a custom-fitted thermal comfort liner, sometimes called the Union suit. It had sewn-in tubing, which circulated cold water pumped from the portable life support system. The system cooled the astronaut during intense sunlight exposure on the moon. Without it, their core temperature would rise in minutes. Over 300 feet of tiny tubing, sewn into a network no wider than a spaghetti noodle, carried water from a backpack through the chest, arms, and legs. It was quiet, efficient, and invisible. Now, let's look closer at the gloves. These were not simple appendages. They were among the most difficult parts of the entire suit to design. Each glove had a silicone rubber bladder, fitted with a Teflon liner and a pressure restraint layer. But what's stranger still was the fingernail protection system. Yes, astronauts often lost fingernails in early EVA training. Why? Because in the vacuum of space, the gloves inflated like balloons, and without structural support, the fingertips of the glove pressed relentlessly against the nail bed, painful, sometimes debilitating. So, Playtex engineers added rigid fingernail caps, a kind of soft armor to prevent injury, a quiet solution to a quiet problem, hidden beneath white outer gloves, never mentioned in public briefings. Then there was the command module pressure gauge, a small instrument embedded in the left wrist. If the suit failed, the astronaut could check instantly whether internal pressure was dropping. It was the last chance to fix a leak. A reminder, always visible, that safety was temporary. The helmet, too, held its mysteries. Constructed from polycarbonate, it was impact-resistant, pressurized, and locked into place with a twist seal ring. Inside was a gold-coated visor, designed to protect from radiation. But the astronauts also had a sunshade, a kind of inner curtain they could lower if the glare became too much. No sunglasses, no adjusting, just a gold veil that floated silently across their view. Now imagine yourself in the suit, but also hearing it. What does it sound like? You wouldn't hear space, that's silent, but you would hear the gentle hiss of oxygen flow, the subtle gurgle of water in the cooling tubes, the soft click of the wrist ring locking, your own breath echoing in the helmet dome. And if your visor was up, the faint, muffled sound of dust tapping the suit as you moved across the moon. A quiet symphony of systems, all designed for survival, all hidden beneath white cloth. Even stranger were the personal additions. Each suit had a biomedical sensor layer, a shirt with embedded electrodes to track the astronaut's heart rate, respiration, and temperature. The data was beamed back to Earth in real time. NASA called it the biosensor system. But to the astronauts, it was just the wired underwear. Then there were emergency oxygen ports, urine collection fittings, and defogging tubes. It was not glamorous, not sleek, not futuristic, but it was real. And finally, in one of the smallest pockets, usually on the left thigh, was a checklist, printed on fireproof material, sewn into the suit, folded like a map. Inside were procedures, reminders, step-by-step guides. Sometimes there were tiny photos of tools, and on at least one Apollo mission there were jokes, little drawings, messages from suit technicians. One read, "No snacks in the helmet." Another, "Don't panic, just follow the list." These little touches were never broadcast. They were personal, private, whispered between ground crew and astronaut, between seamstress and spaceman. So now, let us sit quietly with this thought, that every suit that walked on the moon, every televised step, every dramatic footprint, was filled with quiet mysteries. Layers of secrecy not meant to deceive, but to protect. And beneath it all, beneath the beta cloth, the valves, the golden visor, was a person, breathing, listening, sweating, trusting that this strange, soft, and impossibly complex garment would carry them safely between two worlds. No fanfare, no glamour, just a suit, just enough. And for tonight, just this image to drift off to. A man alone in the dark, wrapped in silence, floating in the void, held not by rockets or steel, but by cloth, tubing, thread, and the careful stitches of hands that never left Earth. These were the quiet figures behind the Apollo spacesuit, the administrators, division chiefs, engineers, and government liaisons. Many worked in windowless offices in Houston or Washington, D.C. Some spent years inside the bureaucracy without ever meeting an astronaut, but their fingerprints, metaphorically, were sewn into every layer of every suit. This was the home of the Crew Systems Division, a collection of engineers, physiologists, and systems managers responsible for everything worn or carried by astronauts. It was, by all accounts, not glamorous. A building of linoleum floors, flickering fluorescents, and humming vending machines. Here, engineers like Joe Cosmo and Al Rochford spent long hours testing suits in vacuum chambers. They wore button-downs and pocket protectors, but it was rarely spoken aloud. They communicated in memos. Not emotion, but equations. Not fear, but tolerances. Now, imagine walking into a NASA conference room in 1966. A coffee pot in the corner. A chalkboard lined with sketches. Men in white shirts leaning over blueprints. There were no women in the room, not usually, though many women worked in administration, data entry, and suit assembly. The engineers were almost exclusively male. But what they were really talking about was whether a human being would live or die. Sometimes the stakes were abstract. Other times they became tragically real. Every component re-reviewed, but also reinforced a quiet fear that even the best designs could be destroyed by oversight or politics. Politics, a word that rarely appears in the story of the Apollo suit, but was quietly present in every meeting. The suit contract had been awarded not just because of technical merit, but also because of optics, relationships, and lobbying. And they operated quietly, with enormous influence. Their executives worked from polished offices in Connecticut. Conference rooms overlooked well-manicured lawns. They met with Pentagon officials and congressional staffers. They didn't sew, they didn't test, they negotiated, and their decisions shaped the lives of every suit, technician, seamstress, and astronaut. Spacesuits were not just engineering projects, they were political symbols. A poorly presented contract could be seized by rivals. A cost overrun could appear in the New York Times. So, suit development was reported not just in inches of mercury and layers of mylar, but in PowerPoint slides, budget briefs, and coded memos. Let's pause here and consider a figure like George Low. Low was a key NASA administrator, not an engineer, but a leader. He understood systems, personalities, and risk. He didn't design spacesuits, but he approved the funds, chose who got meetings, resolved disputes between contractors. He rarely touched a wrench, but he held lives in his calendar. Or think of Deke Slayton, head of the astronaut office. If an astronaut disliked their suit fit, Slayton would quietly lobby for fixes or dismiss the complaint. He was pragmatic, blunt, sometimes quietly feared, but he too was part of the quiet elite. Then there were the contract lawyers. They sat in cubicles, poring over invoices. Did ILC charge too much for zipper number 8729-1B? Was the cooling system over budget? Most never saw a suit, but they tracked every dollar. In this world, money moved as carefully as oxygen. Meanwhile, on the outside, in the public world, the suit was mythologized. Magazines praised its beauty. The suit was still a problem to be solved. Too heavy, too expensive, too complex. The engineers knew the truth. It worked, yes, but just barely. Every EVA was a controlled emergency. And those who made the suits knew something else, too. They went home to quiet homes, ate late dinners, filed reports. They watched the moon landing on small televisions, heard the words, "That's one small step," and knew they had helped make it possible. But no one would ask them for autographs. And maybe that was okay, because the work was its own reward. And for many of them, the suit was the most intimate contact they'd ever have with space. The engineer who triple-checked his math after his kids were asleep. The secretary who scheduled the suit fittings. The Hamilton exec who cut a deal that saved a mission. They were the hidden scaffolding of the space program. Not astronauts, not seamstresses, not test pilots, but the spacesuit elite. Not famous, but essential. Let the rhythm of this long journey settle in your mind. You've traveled slowly, gently, through the overlooked corners of the space program. Not through launch countdowns or iconic moonwalks, but through the endless small steps that made the giant ones possible. The rooms were small, the lighting dim, the budgets tight, the rewards quiet, yet the work was real. Hands that stitched, hands that signed contracts and wrote memos in the middle of the night. They worked in heat, in cold, in stress. They worked under fluorescent lights that buzzed overhead, and they worked knowing that one mistake could cost lives hundreds of miles above Earth. And still, they kept going, because the suit was more than a garment. It was a promise, a cocoon, a tiny, floating room for a single, very vulnerable human being. Think of that suit now, or in a sealed archival crate, faded, dusty, its gold visor dulled, its fabric stiff from age, but still, somehow beautiful, because it was never meant to last forever. It was meant to protect, to serve, to endure, just long enough for one more mission. One more EVA, one more breath. And maybe now, as you lay quietly in the dark, the hum of the past still echoes softly. The sound of sewing machines beneath a Delaware floor. The tapping of a pen against a clipboard. The gentle hiss of air in a pressure test chamber. It's all far away and long ago, but it brought us here. To a world where astronauts walk in comfort, where suits are lighter, safer, smarter, but they still carry that legacy of cramped basements, of unrecognized names, of long hours in invisible rooms. And so do you, because history, even the boring, forgotten parts, belongs to all of us. It surrounds us. It builds the air we breathe, the pillows we sleep on, the dreams we drift into. You are grounded. The work is done. The shift is over. And the stars, silent and distant, are still out there, watching over us all. Good night.